Students, on this video I examine ratio and proportion in depth. There's a few different methods that I use compared to what you probably learned in high school. I hopefully showed you these in class, and if you don't fully understand them, please address them in class or during my office hours. But pay close attention to the different types of problems, when I give you a ratio, when I don't give you a ratio, how it is that you determine which type of ratio that you've got, and how you proceed from there. Let's go ahead and take a look at our first example now. Let's take a look at our first example. The ratio of men to women is 3 to 2. If there are 36 men, how many women? First of all, anytime that I know I have a standard ratio, the easy way to do this is to write it as a fraction. In this case, the ratio of men to women is 3 to 2. The ratio of women to men, of course, would be 2 to 3. The way to determine which way you want to write the equation is to look to see where the variable is. The unknown, which will be my variable this time, is the number of women. So I would like women to be on the top and men to be on the bottom. It's always easier if your known is on the bottom and your unknown on the top. So my ratio of women to men would be 2 women for every 3 men. In this case, I have an unknown number of women, but the number of men is known to be 36. Now, the simple thing to do is to multiply both sides of the equation by 36. Doing this, and doing my arithmetic, gives me an answer of 24. Now, you've probably been taught to cross multiply and divide in the past, and that also would be an acceptable solution here. It would take 2 steps instead of 1. I simply take 3 times W and set that equal to 2 times 36. Divide both sides by 3, and I get my same answer of 24. But what I'd really like for you to notice is that these are actually equivalent fractions. All you have to do this time, and this is a nice shortcut for you to remember, is ask yourself, what do I have to do to the 3 to make it a 36? In this case, I would multiply the 3 by 12, and it becomes a 36. Whatever I do to the bottom, I merely do to the top, and I have equivalent fractions. I'm in essence multiplying by 12 over 12, which is 1, which is legitimate to do in any fraction. So I know 3 times 12 again is 36. 2 times 12 would equal 24 and would give me the answer to my question. Let's take a look at another example. In this case, the ratio of men to women is 3 to 2. If there are 120 people, how many women are there? This is a more difficult problem. In this case, since I didn't say men or women, both are unknowns, I'm just going to write it the way it was given to me. The ratio of men to women is 3 to 2. Now I don't know how many men there are, so I'm going to put M on the top. What will I put for the number of women? Well, you have a couple choices here. We could actually work this out as a 2-variable equation. I could actually go ahead and put women on the bottom and then make another equation up. But I think truthfully what's easier for most students is simply to do this. If I have M women, M men, how many women do I have? Now, Luann, I don't know the answer to that question, but I can probably guess you can figure this answer out. Let's make up a number for the number of men. Now, keep in mind, there can't be more than 120 total, so the number of men has to be less than 120. So pick a number less than 120 for me, any number you'd like.
84.
Well, let's keep it to be a round number to keep our arithmetic easier for Dr. Jones, please. How about a nice round 80 instead?
Okay.
Let's assume that that's 80 for the number of men. How many women would you assume that there are? Now remember, there's 120 altogether. If there's 80 men, how many women would there be?
40.
You're exactly right. And how did you come up with that arithmetic? What did you do with the two numbers, the 120 and the 80, in order to come up with the 40?
I subtracted them.
Correct. You took 120 minus the 80. Now, of course, we remember that that 80 was just a number you made up. The real number, if you will, or variable actually, is an m. So I simply take the 80 away and I put the m in its place. And there would be 120 minus m, number of women. Again, I just took the total of 120, subtracted the number of men, which was m, and that left me with the number of women. Now, you could have, as I suggested before, have actually used a two-variable equation if you prefer. I would say 3 over 2 equals the number of men over the number of women. And the other piece of information we knew in this problem was there was 120 total. So I could say men plus women equals 120. Now I'll solve this for W by subtracting men from both sides of the equation. That would leave me with just men equals, or women, excuse me, equals 120 minus m. And then I could substitute in my original equation where I had the W, I will get rid of that, and I will put in the equivalent 120 minus m. But do you see that both equations are now equivalent, and it really doesn't matter the approach you use? At this point, what I would simply do is cross multiply 2 times m equals 3 times 120 minus m. Multiplying through gives me 360 minus 3m. I would now add 3m to both sides of my equation. And this would leave me with 5m equals 360. Dividing both sides by 5 gives me m equals 72. Now, if there's 72 men and 120 women altogether, or 120 people altogether, I can find the number of women by merely subtracting my 72 from my 120. In this case, 120 minus my 72 gives me 48. So that'd be 48 women. Now, I'd like you to see one more shortcut here, though. Really, what would be easier, since your given is how many people there are, and your needed or desired quantity is the number of women, what would be nicer is to put that unknown women on the top and the people on the bottom. In this case, what would the ratio be? In our ratio, there were 3 women. How many total people would there be in our ratio, Luann?
5.
Because there are 3 men and there are 2 women, that's a total of 5 people altogether. So the ratio of women to people in the ratio would be 3 to 5. Frankly, another way to say that would be 3/5 of the people would be women. At that point, what I will do is I will indicate the number of women, which is unknown, over the number of people, which I do know to be 120. And now, again, I could cross multiply and divide, multiply both sides by 120, but I'm going to take advantage of that shortcut that I showed you before. I will take 5 times 24 to give me the 120. Oh, and I've made a mistake here. This was the number of men in the ratio. This should have been 2 women in the ratio, is a total of 5 people. I apologize for that, but the way you work the problem is the same. I take 5 times 24 gives me the 120. My 2 times 24 will give me 48 women. So again, it doesn't matter which way I work out the problem, there are indeed 48 women. Let's take a look at my next problem. In this case, I've told you that it takes 4 hours to paint 3 walls, and asked in turn how long it would take to paint 5 walls. In this case, I have not simply come out and told you that it's a ratio. So we have to figure out, first of all, if it is a ratio. To determine that, basically what you need to know is the answer to this. Do the 2 quantities given, in this case hours and paint, or excuse me, hours and wall, do those act proportionately? In other words, if we have twice as many hours, can we paint twice as many walls? Or, if we have twice as many walls, will it take twice as many hours? And that's what I mean by proportionately. And in this case, the answer is indeed yes. So we will again set this problem up with a standard proportion, and work it like a standard ratio problem. In this case, my unknown is how long, or the number of hours it takes, given the number of walls. So I'll put hours over walls. In this case, I know it takes 4 hours to paint 3 walls. How many hours, H, does it take to paint 5 walls? Now, to be honest, to use my shortcut this time would be a little trickier. Multiplying what times 3 would give you 5? The answer is 1 2/3, and if you actually see the problem that way, then I encourage you to go ahead and do that. But again, I think what most students would do here would be either to cross multiply or to simply multiply both sides by 5. In this case, the 5's cancel. On this side, I have 5 times 4 is 20 over 3. So the answer is, it takes 20/3, or 6 2/3, or 6 hours and 40 minutes. Any of those answers are acceptable to paint the 5 walls. Let's take a look at our next problem now. It takes 3 men 4 hours to paint a room. How long would it take 5 men? Well, let's examine this to see if this is also a normal proportion. In this case, if it takes 3 men to paint 4 hours, if it takes 6 men, would it take twice as long? And the answer this time is no, it wouldn't. Obviously, the more men you have, the less hours it takes. Again, in a normal proportion, if this was a normal proportion, the more men you had, the more hours it would take. And that is not the case here. So what we actually have is an inverse proportion, or an inverse ratio if you prefer, but I prefer the term inverse ratio, or inverse proportion. As this number is going up, this number should actually go down. Well, in a normal proportion or a normal ratio problem, we simply put one thing over the other. For example, if we look back here for just a minute, when we were talking about the ratio of men to women, we merely put 3 over 2. Well, that in between would be division, of course. That would be 3 divided by 2. Since this is the opposite, as one number gets bigger, the other number gets smaller, logically, what would you suppose you would do with those two numbers? What's the opposite of the normal division in a normal proportion problem?
We're going to flip them. We're going to multiply them.
Well, that's right. You'll multiply. It's the opposite of a division problem. So in this case, instead of putting men over hours, I will simply take the number of men times the number of hours. In this case, we know it takes 3 men 4 hours to paint a room. And that has to be equal to 5 men take how many hours to paint the room? So 3 times 4 is 12, equals 5h. Dividing both sides by 5 leaves me with an answer of 12/5, or if you prefer, 2.4, or 2 hours and 24 minutes. Again, I will accept any of those answers. And you'll notice that Luann actually suggested that I use the inverse, or the reciprocal, of the ratio. If you wish to actually flip and you've set up the ratio correctly, that's the way most teachers actually prefer that you do the problem, but to be honest, it's a little more complicated than simply reversing one of those ratios. And I prefer that you simply set it up as multiplication. But that's my opinion. You can feel free to ask me about that in class or during my office hours. Finally, I have one more example to show you. In this case, it's a little more complicated, because I have 2 men, 6 hours, and 3 rooms. It takes 2 men 6 hours to paint 3 rooms. My question is, how long would it take 3 men to paint 2 rooms? Now, this is a combination or a joint variation problem. I want you to try to figure out what to do with the placement of these 3 things. We have men in relation to hours in relation to rooms. Now, Luann, I'd like you to pick 2 of those at random. What would you like to pick?
Men and hours.
Men and hours. Now let's go back to determining whether that's an inverse proportion or a normal proportion. The more men you have, the
Less time.
fewer hours, and that makes it an inverse proportion, so I need to multiply the men times the hours. That leaves us with rooms. Now, Luann, which of these would you prefer that I associate with rooms, men or hours?
Hours.
Hours, fine choice. Let's talk about whether it's a normal or an inverse proportion. The more rooms you have, the
Longer it takes.
more hours it takes. As this number gets bigger, this one gets bigger proportionately. If you have twice as many rooms, it takes twice as many hours. So that's a normal proportion. If I already have hours on top, rooms would therefore have to be on the bottom so that you'd have hours over rooms. Now let's compare our last combination. We have rooms and we have men. Once we compare these, we've compared all possible combinations. Once again, the more rooms you have, the
More men.
more men it would take to paint the rooms. That's exactly right. Once again, if you have twice as many rooms, it takes twice as many men. That's a normal proportion. Again, one thing has to be on the top, the other on the bottom. So in this case, men would have to be over rooms, and it is. So, let's go ahead and fill in the blanks now, if you will. In our first example, we had 2 men. It took 6 hours, and they were painting 3 rooms. In the second example, we had, 3 men. We don't know how many hours it's going to take, but I do know that it's 2 rooms. Now you have a lot of possible ways you can work this problem. You could cross multiply, you could simplify first. There's again a variety of ways you can do it. What I would like to do first, I think, is simplification. In this case, frankly, I would just take the 3 into the 6, goes twice, and 2 times 2 is 4. I'll leave the right side the same. And now, again, you could cross multiply, but I think I will multiply both sides by 2. 2 times 4 is 8, equals 3 times h. And in my last step, I will simply divide both sides by 3. So it takes 8/3, or 2 2/3, or if you prefer, 2 hours and 40 minutes in order for these 3 men to paint the 2 rooms.